Hi, this is a short video to explain the main outcomes of the Interlink pilot in Polifonia and how these outcomes can be interesting to the members of the stakeholder network. I'm Jacopo de Berardinis from King's College London and I'm representing Interlink. So let's start. Well, because musical data and musical knowledge is scattered across a number of disconnected resources on the web. And this is a major problem for music researchers, as it is kind of limiting our ability to find relationships from heterogeneous data, and so our overall ability of understanding music as a whole. For example, Wikipedia and Wikidata, they provide information about, general information about music, events, and artists. MusicBrainz provides metadata and cataloging information. Songfacts provide curiosity about the music and the relationship with the places and photographs, for example. Genius provides information about lyrics and curiosities about the lyrics. And other databases like WhoSample provide information about patterns, samples, structures that can occur from different pieces. In addition to music information retrieval datasets, of course, which individually represent a great deal of musical knowledge as they provide musical annotation, expert musical annotation. But unfortunately, all these datasets and all these databases, which we mentioned, are not designed to be used together, jointly. And this is why we need to join forces to bring all this musical knowledge together in the same place and make it available to everyone for free. In Interlink, we started this investigation following three main steps: connect, enrich, and explore. For the first step, we are using semantic web technologies to create the largest interconnected musical knowledge graph on the web. We use the Polifonia ontology network to semantically integrate a number of heterogeneous music datasets and perform entity linking to establish meaningful connections. For the second step, enrich, we are leveraging state-of-the-art methods in music information retrieval to analyze musical content, both audio, scores, so symbolic music, whenever it is available in the knowledge graph, and we extract meaningful information from it, such as patterns, structures, emotions, musical complexity metrics, and so forth. So this allows us to introduce additional links in the knowledge graph based on similar musical properties. For example, we could discover new connections among artists and songs which were previously unknown. And finally, in Explore, we are designing novel ways to interact naturally with the rich and diversified, heterogeneous, multimodal musical knowledge in our graph. We want to minimize any barrier between the final user and all this musical knowledge so that we can enable new application and workflow in music education, listening, recommendation, discovery, and research. At the moment, we are working on two parallel directions, one focused on connect and the other focused on enrich. The former is related to the challenge of interconnected music information retrieval datasets. As we were mentioning before, they're isolated, they're disconnected, they're fragmented. But more generally, we want to integrate any dataset providing musical annotations such as chords, structures, patterns, emotions, and so forth. For this, we have already extended a popular standard in music information retrieval, GEMS, to support score annotation. We implemented semi-automatic methods to create GEMS datasets from the original data sources, and we designed a fully fledged workflow to produce music knowledge graph from GEMS datasets. We have already applied our integration framework on 18 different harmonic datasets, and we are releasing this output as the largest chord corpus to date. Choco. In parallel, for the enrich objective, we are devising novel methods for music structure analysis and music similarity that can be explained and interpreted under musicological perspectives. Together with the other endeavors in computational music analysis, this will provide an interrelated view of the harmonic and melodic structure emerging from different collections, while preserving a level of explainability to semantically describe their content. Well, we are looking forward to interacting and collaborating with any industrial and academic partner that can contribute to or benefit from our 3 steps: connect, enrich, and explore. For Connect in particular, we would like to engage with the curators and the maintainers of music collections and databases. So if your goal is to improve the interconnection, the accessibility, and the impact of your music data, please contact us. For Enrich, we welcome collaboration with experts in music information retrieval and computational musicology, specifically for computational music analysis, of course. Our priority is to extract meaningful and explainable descriptors from the musical content, which can be semantically described. And finally, for Explore, we are really keen to work with museums, cultural age institutions, and experts in digital humanities, which can leverage our musical knowledge graph and create novel applications for more engaging and memorable music experiences. That's it. Thanks for your time watching this video, and please get back to us for interlinking. Thank you.